So I was just going to start and ask each of you, Roger just said a little bit about the challenges going forward, but one of the things that was passing through my mind was that to a large extent, all three of you are addressing major challenges facing the world. Either it's congestion in cities impeding economic development and so on, or it's climate change. How long do we have, do you think, to really go from what are proven prototype technologies on relatively small scales to worldwide application of these sorts of solutions? What sort of timescales are we talking about for each of the sort of instrumentation that we've been talking about today?
Sure. Okay. So I think that for the mix of things we're talking about, we can imagine that 5 to 10 years from now we'll have a wide suite of new observations. And I think the challenge that I think we're talking about here is how we take that information and package it in ways that are useful to people at a variety of different interest levels and experience. So we, in the public policy group at the end, we were talking about delivering information to experts who were used to staring at scatter plots, whereas other people can only look at bar graphs. And I think we have that same kind of situation here of how can we package these different kinds of information in ways that are interpretable to people who have different interests and communication needs. And I think that's the conversation we should continue today.
In terms of traffic, it's a very long time scale. I think the technology, a lot of the technology is actually mature to be deployed already. And in fact, there are some test beds all around the world which have implemented these types of technology. I think the pioneers are probably in Australia and in the Netherlands. I think hopefully with California will soon also be at the forefront of what's being done. The case of traffic is a bit different than the case of atmospheric chemistry in the sense that most of the difficulties we face are institutional. So there are, of course, issues of funding because you need to deploy the infrastructure. But then once you have the technology, the main question is how you're going to deal with the plurality of jurisdictions. For example, if you reroute traffic in the arterial network, counties and cities will not like it. But that's what the California DOT would like to do as a state mandate. Vice versa, you can't flood arterial traffic into the freeway because you congest the freeways. So the time scales at which things will happen are very gradual. And unlike a system in which overnight you could say display all the information happening in a building because you just implemented it, here what you will see is you will see a very progressive adoption of the technology, and you will see a progressive change of things where on the first day they might only meter a couple on-ramps. On the second month they might do a little bit more until the public finally accepts. So for transportation in a nutshell, it's really more of a social acceptance and institutional acceptance issue than a technology issue.
Roger.
I have this mic. Yeah,
yeah,
just a couple of things. I'm working with the water industry, which has traditionally been very conservative and slow to adopt innovation as compared to, say, weather forecasting, which has moved much faster. But I'm encouraged by the leadership in California and other places working to find ways to finance and bring this technology into decision making. That said, we can look at the government of Australia, made a very large public investment in water information system, but it was precipitated by severe water stress. I hope we don't have to go that far before we start making, bringing better information into decision making.
Any question? I have another one, but if anyone has to, we'll go the old-fashioned way and people can shout them out. I'll ask my second question, which is what role do you see a citizen, the public, having in each of your areas in pushing adoption of these technical solutions to the problem? I think, Roger, your point about a water crisis precipitating investment, which we don't want California to get to that point of LA running out of water, although some people might be quite happy with that to happen. But Ron, you have the issue of climate change has been difficult for people to buy into. So what role do you see the public having, and how can you engage the public quickly to push this forward? Do you want to start, Ron?
Sure. I'm not going to claim to be an expert in the public opinion of climate change. I think that there are lots and lots of reasons why the scientific consensus on climate change is widely accepted in most of the world and less so in the United States. I'm certainly hopeful that the comments that Obama made in the inauguration speech last week might be a sign of a little bit of a change here in that. But I think that what we've seen is, even here in the U.S., that at the local level, there's lots of interest in trying to do something. So independent of a national consensus, individual states and individual municipalities are really trying to do something already. And so I think the question I have is, as a scientist working on that, is what can I do to provide good data and synthesis of information to both the public in those locations where they're interested in and the policymakers there, so that they can make good decisions. And what form does that take? And so that, I think there we have an opportunity for real progress in lots of different ways. And here in California especially, where we've already made a commitment at the state level to regulate the climate-related gases, I think we can pave the way in a lot of different ways in the strategies for providing information to the public and policymakers that are useful.
On the transportation side, things are slightly different. That's mostly because the user is the problem, is part of the problem. So you can't really do something you would do, for example, with air. Say, okay, it's from tomorrow it's going to be prohibited to burn wood in your fireplace. Like there are a lot of cities where you cannot construct a house where you burn wood. But it's unthinkable to think that Oakland would prevent anybody living in Oakland to enter the freeway in Oakland because it's congested. You just can't do that. You can prevent people from burning wood, but you cannot prevent them from entering the freeway. So the main issue and the main difference is that the public agencies have very limited mandates. As soon as they're going to try to enforce something, for example, high speed tolling or any kind of tolling scheme, then you're going to have issues with the public. You can see other countries like Singapore, where the law makes it much easier for the government to start tolling freeways, and they can be a lot more proactive in controlling, I would say, things at a global scale, which you cannot do here. So that leaves basically public agency with an alternative, which is very tentative and which is just at its infancy, which is incentivization. And it's a very interesting problem because it's not clear how it's going to work, but it might be that one of the few ways to decongest freeways and to decongest the transportation network is going to give incentives for people to change their patterns, which could mean more work from home, which could mean changing your itinerary, or which could mean changing the mode of transportation you use. For example, using transit instead of using your car. And there are a lot of interesting experiments which are run, some of them out of Stanford. Some of them we're interested in doing here. And I think the underlying problems that are very interesting to solve in this space is the notion of leader-follower games. There's an effort which was just announced will be announced actually, in a couple days, led by our dean, Shankar Sastry, called the Forces Effort, which deals with these kinds of problems, and we're part of it. And here, the types of problems that you have to solve is, say you could reach out to 5% of the population. Say you can give an incentive to 5% of the people to actually leave the freeway at a given time to go and take a cup of coffee or collect $5 of coupon by shopping right now at this location instead of clogging the freeway. How do you do this optimally so that the 95% remaining percent of the people who will act selfishly, because we all do act selfishly by trying to choose what's the best for our commute at the detriment of the common good. So how do we choose these 5% so that the 95% remaining selfish 5% of the users really produce something which is optimal at that scale. So these are game problems which are fairly interesting and that are at the center of what people are trying to do now to improve things. And one of the difference, maybe in conclusion, to what can be done in air is, if you can touch 5% of the traveling public, you're God, because it's an enormous number, and that's very different than prohibiting everybody from burning wood in their fireplace, which technically could be done overnight in given cities. So actuation of people is difficult.
Thank you, Alex.
Yeah, I think there's a question.
Yeah, I have a question which is really a brass tacks question, which is how much did the data cost that you bought and how did that process work?
So it's a very interesting question because we went into this without knowing what we were doing because it's never been done before. And so maybe the first question is how much does that data cost? So again, I can't give you a price per GPS point, but the typical things that you will find today in the practitioner's world is people won't charge for data as much as for a service. So companies like INRIX, for example, will charge you something like $800 per mile of information, and they will send you information for a specific mile of freeway. That's one way to price things. Other ways to price things that we have investigated with the state of California would be to give a range of price for a given number of GPS points per hour, per day, over a certain period of time. And there you have to be very careful because then you could be tricked by people sending you GPS in the middle of the night because it's trucking and there's a bunch of trucks, but that's useless for traffic management. So you can have a lot of different pricing schemes that can be used. We have experimented with several of them, and I would say the two most common today that you see in the practitioner's world is either to charge for a service, so you buy information for a given set of the freeway or the network, or specific specs in terms of data, amount of data, and then you agree on the price. And the prices in that particular case I cannot reveal because they're part of a confidential agreement, but you can give ranges, and it's a bidding process like any other RFP. Does that answer the question?
No, it doesn't answer my question.
Okay, so ask again. I'm sorry. No, go ahead. Ask again.
Well, I wanted to know what the actual price was.
Okay, so for that, we would have to have a follow-up conversation.
Just one last question right at the back.
Sure. So I think we can imagine many loops between the data, audiences, and action or change. I mean, one I think that bears some attention is regulation. A lot of regulation, the action part of regulation is limited by the data. We, for example, have air quality standards, but limited air quality data to drive those standards. There's parts of our cities that are missing this data. So I think the data here, both approaches, either using traffic data to model air pollution or satellite, could potentially drive regulatory actions within the Clean Air Act or other regulations themselves. I think one of the difficulties there is that the measures that are being produced through, I think, some of these new technologies are not the measures that are codified as action-driving metrics within regulatory standards. So that either requires changing the regulations to align with new measurement technologies or allowing the old anyway, that alignment. So I don't know if you've been, I mean, I think that we've had to struggle with this. We've struggled with this in creating new data to use the existing regulations. But I'm wondering how much the regulatory use of the data is playing part kind of in your thinking about data collection, because it can be very, very powerful if there's an existing law. New regulations are heavy lifts.
I guess what I would say is we're very interested in the idea that we can provide information during the implementation of some regulation to evaluate before or after, even if the measurement is not the specific data point as specified in the regulation. The information can be used to evaluate the effectiveness of that regulation. So, for example, the satellite images I showed you are not part of the Clean Air Act, and they wouldn't satisfy the regulatory rule in the Clean Air Act. But they tell you a tremendous amount about the success of that law. And they can follow individual power plants. We can follow cities. So we can see the success at, not at the corner scale, but at the 10-kilometer scale. And I think that's the kind of thing that can be very useful, independent of whether it's specified in the regulation.
I'll answer that from the water side. Expanded to say verification, whether it's for regulatory or a market. And in the water side, the data don't exist to do that, but verification is going to be critical. I mean, you ask some of my water colleagues, what's the key to, in the operational side of it, what's the key to a secure water supply, a better lawyer or more data? And you'll get both answers, but actually they go together.
Thank you, Roger. Camille is looking at me and saying, if you don't stop now, I'll kill you. So I'd like to thank the panel very much for a very interesting